Dear colleagues, I would like to thank the organizing committee for kind invitation to take part in a Russian Thai Roundtable. The aim of my report is to acquaintance with the structure of multimedia physics textbooks for the secondary and high school, and to discuss the methodology of working with textbooks, their possibilities in increasing the effectiveness of training, including distance learning. What is the main task facing physics teachers? The main task is to awaken curiosity in the student. How to do it now, in the era of increasing information flows, when is it difficult to surprise students? The teacher should get away from chalk physics, but not into the world of computers animations. Physics is an experimental science. Therefore, experiments should be at the forefront of physics education. Not paying enough attention to experimental methods significantly distorts the logic of teaching physics and reduces the level of understanding of basic concepts. As a result, there is a loss of interest and a lack of positive motivation for students to continue studies in study physics and the other sciences. It is necessary to give the educational process a research character to enhance the role of the experiment and its discussion. Multimedia technologies come to the rescue, allowing effectively transfer information through the video, sound, animation, graphics, and text. So, the information technology revolution has to find the reflection in new generation of textbook. Multimedia textbook should stimulate cognitive interest and learning activity. Textbook contain a systematic presentation of the entire physics course, from mechanics to the atomic nucleus. The scripts of multimedia textbook are written on the base of a paper textbooks, which are approved by the Ministry of Education of the Russian Federation. Every paragraph of our textbook is a sequence of a short, approximately 2 minutes duration, lectures fragments. Lectures fragments are alternated with small problems. After each paragraph, there are blocks with additional problems divided on 3 difficulty levels. This is a fragment of the page content. On the left side, there are the names of the chapters and paragraphs. If you will click paragraph, you will see the paragraph content on the right side. Let's introduce with the lectures fragments. During the lecture fragment, new material is presented, experiments are demonstrated and discussed, examples of problem solving are shown, etc. A voice-over comments what is happening on the screen. The lecture is not a teacher's monologue. We try to maintain a dialogue with the students through small questions. The screen of the lecture fragment is divided on 2 parts. The left side is a demonstration table. We show here videos, animations, pictures, etc. The right side is a blackboard. Here we write down formulas, definitions, and formulations of laws. The students should write down this information into his paper notebook. On the down we see the video players tool. Let's see the example of the lectures fragment dynamic of circular motion. Because the voice-over in Russian, I will translate in English. How are connected the directions of the resultant force, the acceleration, and the velocity of a point in uniform circular motion? Let's see the experiment. We can see that the threads deviated from the vertical. Where is the acceleration of the balls directed? Appear question, and the students have to give answer. I show the students' choice. Okay, good. So, the acceleration of the balls is directed towards the center of the circle. There are two forces acting on the ball: gravity and thread tension. You have to draw the thread tension in the figure. Take the end of the vector t and drag it to the circle. Vector F will show the resultant force, T and mg. I show the student's choice. Check answer. Wrongly. Students can use hints and to find right answer. Check. Right. So, according to the Newton's second law, the direction of acceleration coincides with the direction of the resultant forces applied to the body, etc. During the lecture's fragment, we have discussed the life experiment and used interactive tasks. In our multimedia textbook, we use some original educational resources. One of them is video problems and video questions. Picture is worth 1,000 words. The content of a video problem is presented as a movie. Let's see the example. There are two identical rectangular prisms. Let's make a cube from these prisms. I will put the plane mirror parallel to the diagonal of the cube. On the side of the cube, I put the letter M, and on the back, I put the letter Y. You can read the Russian word It means mind. Let's put this sheet on the paper between the prisms. As before, you can read Let's pour water between the prisms. The letters trade places. Please explain this phenomena. Why do the letters trade places? The video problems are the problems with incomplete content. As a rule, it is unusual problem formulation, physical trick. For students, it is difficult to understand why has happened, what is given. The video problems teach students to recognize physical phenomena, forces to independently to build a physical model. This form of work is more effective in stimulated interest in physics and in the development of creative abilities. In the textbooks, we widely apply a research approach. We call this method as method of key situations investigation. The essence of the method is to teach a student put the questions and find answers to them. We take a physical situation and investigate it together with student step by step using small questions. Let's look example. The figure shows the cycle of the ideal gas. Calculated the efficiency of this cycle. Question: what are the stages of this cycle? The student gives answers and fill the table. Check answer. Good. Now we will give next question. In what stages does the gas get the heat? Use the first law of thermodynamics. Consider a stage A, isochoric heating. Next question appears on the screen, and the student gives answer. Good. And so on. A large number of physics problems are included in the textbooks. Every time, the quantities data in the problems are changed when you access to the task. Look some examples. Tasks with the graphs. The graphs change every time when you turn to the task. One time, one graphs. Another time, another graphs. Tasks with the numeric data. We see that the numeric data change when you turn to the task. Here are some quantitative characteristics of textbooks for high school. There are 260 video demonstrations of physical experiments, 380 animation models, including interactive ones, 2,700 questions and physical problems, more than 1,000 pictures and photographs. I would like to stress that our software allows easily change the textbook content, add or delete individual elements, and translate into other languages. We can suggest to translate this textbook to Thai language, taking into account the particularities of the national education standards. How to use a multimedia textbook in distance education and during pandemic. I would like to share our experiments during this period. Our students had access to the multimedia textbook and installed it on their computers. The teacher indicates the section that the students should study independently. Listen lectures, fragments, answer on questions, and solve problems. At this stage, the teacher is in the background. It should be emphasized that at this stage the internet is not needed, which significantly reduced traffic. The teacher's role increases at the next stage, at the stage of online communication. The teacher makes some explanation, additions, calculations, and solve problems. The teacher works with students familiar with material. It significantly improves the effectiveness of learning. Using this method, the teacher spends less time for explanation and new material. He has more time for discussing difficult parts and solve problems. This is my colleagues. Thank you very much for your attention.